Hello and welcome to episode 2 of Bicep for Real. And this week we're going to get started on actually writing code and deploying some of our environment. So let's get into that. So you remember from last week we are going to be working on creating the infrastructure that's going to run Lambda Toys' new digital store project. So we've got a container-based application that's going to be running on our infrastructure, and we need to build everything that it needs to be able to run. This is our sort of high-level network diagram from last week, and you see it's fairly simple. We don't have too many moving parts yet. I'm sure some will come along, but we're going to get started this week with building out some of this environment. We're not going to try and do everything at once. Particularly, we're going to avoid the application level piece at this point, so the container hosting, the application insights, that sort of thing. We're not going to hit that yet. That's going to be fairly complex. We'll probably have a whole episode on sorting out the container side of thing. But we are going to start with some of the core resources that everything else is going to depend on. And that's really going to be around the virtual network, the network security group, and that sort of stuff. So we're going to start creating our first Bicep files to deploy that network to our environment. Now, if you remember last week, we had these requirements. I've just have a quick look through them, see what might be applicable on the networking side here. Obviously, we're going to do it in Azure, we know that. Don't need to care about the container-based piece, the Dapper. We're not going to probably get to the database today. We do need to use private endpoints, so we do need to think about that a little bit when we do our deployment. We're going to come to the API a bit later as well. We're going to need 3 different environments, so we need to make these reusable. We don't want to be writing Bicep files that are completely separate files, customized for every environment. We want to parameterize, so we're going to get that in early and make sure we can customize our files. High availability we're going to tackle later. We're going to build out one environment first and then look at adding the high availability and particularly the active piece on top of that. One of the really key things we're going to focus on here is not trying to do everything at once, because you'll never get anywhere. You'll never get started because you've got too many things to deal with, too many things to think about. So we're going to sort of boil it down to the simplest place we can start and start layering on things. Logging and monitoring, we do want to make a core piece, particularly the infrastructure monitoring, so the log analytics piece. So we'll probably have a look at that if we have time today to do that. CI/CD we'll tackle later. We're going to get a few things working first before we start building our CI/CD pipelines. We're not going to wait till the very end. We are going to do it fairly early, but we need something to deploy so we can test out our CI/CD. And costs should be kept to a minimum. Well, that's going to be, we're going to have to think about that throughout. Networking costs are fairly low, and there's not massive amounts we can do to keep that, below what it already is. But we'll bear that in mind as we start creating. So we're ready to go. Let's dive into Visual Studio Code and let's start writing some Bicep. Okay, so let's get started with building out our code. First things first, a little bit of organization in our repo we've got here. So we're going to create a folder for our infrastructure. And let's create a file in here and we'll call it core.bicep. So we're going to put all the core infrastructure, so the stuff that isn't container apps and those sort of things. Okay, so we've got our Bicep file here. And when I write these Bicep files, the first thing I try to do is sort of think about my interface. So this is the parameters we're going to accept in this file. We're trying to make these reasonably generic so that we can deploy our dev, test, and prod environment with different properties without having to go and edit the actual code. So we're going to want to parameterize that so we can pass in the right parameters to be able to vary them how we want without rewriting. So we will start off and think about how we're going to build our interface. What parameters do we need? Now, you're absolutely never going to get these 100% right the first time you do it. You're going to have to adapt these as you add new resources and realize you missed something or you need something extra. That's absolutely fine. I'm not trying to get everything 100% correct straight off the bat, but we'll just see what we can do to start with. So there's a few things we are going to need. So the first one that is pretty much every template, we're going to need a location. So what region are we going to deploy this into? So let's add one of those. Call it location. And that's all we need for that. We don't need to declare a default for that. So complaining about. Oh, yeah. Okay, next up, a common parameter is going to be some sort of prefix or naming convention. So what you could do with these parameters is you could pass in a parameter for the name of every resource. So you could have a VNet name parameter and VM name parameter and all that sort of stuff. But you're going to end up with hundreds of parameters, each naming different things. So what I tend to do with these templates is follow a process where I pass in some sort of prefix or suffix or something that's going to allow me to uniquely identify the resources in that environment, and then use a naming convention to generate the rest of the name. So a storage account, will be the prefix I pass in plus STG for storage or something like that. Just a way of being able to generate your names without having to pass in every single one. And what you can actually do, and we'll look at this in a later video, is actually formalize that into some sort of naming conventions module, which we can use to actually generate names. We'll look at that later. But for now, we'll just pass in a prefix, a string, we'll spam parameter correctly. Okay, so those two are going to be fairly common across everything else. Okay, so now we're going to have a look at some of the more specific parameters we need for this particular template we're going to deploy. So the first one is we are going to be creating a VNet, and so we need to take in some properties to allow us to customize that VNet. Now you can think here about how much level of customization you want to allow the end user of the VNet. You could just hard code everything and force the user to create the VNet with the fixed IP address ranges and subnets that you want. But that doesn't always work particularly well, particularly if you are having to deploy with IP ranges that are specified by your networking team or something, and you've got to vary them per environment and you don't know what they are up front. So we want to allow some parameters to be passed in for those. Now this, to allow us to be a bit more dynamic, we're not just going to use strings for this, we're going to have a look at using objects. So we're going to create a VNet settings object, and we are going to create some default values here. Now, the reason we're creating some default values here is for two reasons. Firstly, it will allow anyone who's using the template to just use it without filling in any values if they just want to test it out or they're happy with those values. But probably more importantly is we need to give some guidance to somebody who's using the template as to what those object needs to look like. There isn't at the moment any strong typing for objects in Bicep, so we can't actually force a user to enter the values in the right format and the right values that we need. So we need to give them some guidance. Otherwise, if they don't put the right values in, we're going to rely on them being in that place in the object, and when they're going to fail. So we want to give them some examples of what it should look like. Strong typing hopefully is going to come at some point, but at the moment it doesn't. So let's create a sort of default object for this. So the first thing we need is we're going to need some address spaces for the VNet as a whole. You can pass in multiple address spaces for a VNet. You can have, add them all together. So this needs to be an array. So we're going to call this address prefixes, and we're going to make that an array, and we're going to put a default value in. We're just going to add the 1, go with a /20. Okay, so that's the default sort of IP range we'll set up for the VNet. Obviously, people can override that and add more if they want to. Next up, we need subnets. So we want to be able to specify as many subnets as we need. So we'll create another array called subnets, and then we'll create some values in there. And all we really need at this point is a name, and an address prefix. So let's just start at the beginning of the range and go for /20. It's a fairly big subnet. And we'll just leave it at that for now. For the moment, for what we need, we actually only need one subnet. In the future, as we add more things that might need things like subnet delegations and so on, we might need to add more. So we might have to come back and revisit this later, but we'll deal with that when that happens. So let's now go ahead and create some resources. I'm sure we'll need other parameters later that I haven't thought of, but that should do us for getting started with a VNet at least. So let's do that. So we're going to go ahead and create a VNet. We're going to use the snippets that come with VS Code to fill in most of the details for us. If you haven't used these before, if you just type starting res for resource, you can get a sort of blank resource. If you do resource with defaults, you can get a blank one where you can then fill in, but we're going to let it do most of the work for us. And so we want to actually get the VNet one that's already there, and that fills in a lot of this for us. So we can leave the virtual network as is. We don't the name here. We're going to fill in the actual name. So this name here is the name that's given to the resource actually in our template as far as referencing it later and so on. But this name here is the name that actually gets created in Azure. So we can leave this one as fairly generic as virtual network. This one obviously needs to be able to be adapted with our prefix and so on. So we're going to get rid of that, and we're going to use the string interpolation in Bicep to allow us to do this, which just in a string, if you use $ and then curly braces, you can use then a parameter in there. So we want to use prefix, and then we're going to add some string on the end called -vnet to make it clear that's a virtual network, and we can see that by the name. Okay, location is already being pulled in from that parameter, so we don't need to change that. Now we need to get into what we're doing down here with the actual address space and subnet. So let's get started first with address space. So if you remember from our property, we're actually passing in an array. So we don't need to sort of loop and populate any of these or anything. What we can actually do is just get rid of this array and replace it with our VNet settings one. So VNet settings dot address fixes. Unfortunately, you don't get IntelliSense beyond the first level of the object here. So VNet settings, we can't check that, so we'll have to manually just check that those spellings are correct. But that should then pass in that array directly here. And then for subnets is going to be a little bit more complicated, because what we want to do is we want to loop through this list of subnets and apply them all. So we're going to use a for loop. And the syntax for that is fairly straightforward. We just do for, and then we need a variable name that we're going to use. So we're just going to call it subnet, and then in, and then the actual where the thing we're going to loop over is, which is this virtual VNet settings, dot subnets. That's what we're going to loop through. And then we are going to need a name, which is going to be the sub property there. So subnet dot name, that will fill in this name value here into that column. And then we need a properties section, which is where most of the VNet properties are going to live. And then inside here, we need an address prefix, which is the one we're going to pass in here. And so we need the subnet dot address prefix. There. Do that, it needs to be on the same line. And there we go. So what this will do is it will loop through all the subnets in this subnet array. So this array here, it will loop through those, and it will create a subnet for each of those using the name field as the name. And then in the properties section for the address prefix, it will put in that address prefix. And there we go. That's all we need for a VNet at the basic level. Obviously, there's a lot more customization we could do for the VNet if you wanted to, and we'll probably come back to do that later. But that will create us a VNet. Now, at the minute, that VNet's going to be open to the world. It will not have any network security groups on it that will restrict access. Now, not a massive issue right now because there's nothing in that VNet, but as we deploy things, that could become a bit of an issue. So we need to look at applying network security groups. Now, you can apply network security groups at the network card level. So when you deploy a VM or a private endpoint or so on, we could apply them there. I prefer applying my NSGs at a subnet level. That way I can then apply policies across the whole subnet rather than have to tweak individual ones for individual machines. You need to look at your use case and see what you actually need. If you do need different scenarios for different VMs or so on, consider which is the best approach. You can still do it with subnet level ones because you can add rules that only go to certain IPs or application groups and those sort of things. But it's up to you. We're going to have a look at doing it here with a subnet level NSG. So we need to create an NSG. And we actually want to create the NSG before we create the virtual network because we need to apply that to the subnets. Now, there are a couple of ways to do this in Bicep, and it will, well, if we use these NSG in this virtual network in this subnet, then it will create a dependency on the two, and so that will mean that the NSG has to be created before the virtual network. And so that does mean you can actually put the NSG, underneath the virtual network in your script if you want. But I find that can get a bit confusing. Ideally, when I create my templates, I put things in the order they're going to be created for the most part. Sometimes you can't do that. So what we're going to do is we're going to create our NSG first in the template. Again, use the network security group option there. And we're going to use, again, give it a name. So we're going to call this, use our prefix. And we're going to call it default NSG. We're going to call it that because we might need other NSGs later that are specific for a particular resource. So we'll call it that for now, so we can apply that. At the moment, we're not actually going to apply any security rules. We're just going to take the default rules that come with any NSG, which will block inbound traffic and will allow outbound internet access and traffic between the networks. So we'll leave that blank for the moment. We're going to definitely add some rules in later, but we don't know what they are yet. So let's just leave that blank for now. The other thing we want to do then is apply that to our subnets. And again, at the moment, we're going to assume every subnet is going to have that default NSG attached. Later, we might need to change that. We'll deal with that when we get to that point. And this is all about how we refactor these. As I mentioned, if you try and get everything perfect up front, you will never produce anything that works because you'll be faffing and trying to work out how to make things so generic that you can deal with any problem that might come up that you won't actually get anything produced. So start with what you know, make it work, refactor later. So what we want is the network security group, and then we will refer back to this so we can call in network security group dot ID. I think it's ID. Oh, actually, no, we don't need the ID. We need the whole network security group. So to do that, and that will then apply that network security group to our resources. And at the same time, it will create a dependency. So we don't have to explicitly create a dependency. We can just run that and it will work out the dependencies for us. So this should now create virtual network and assign the network security group to that virtual network using the default rules. So before we go any further and start writing anything else, let's just make sure this works. And this is something I recommend as well, is to deploy often, make sure you catch issues as you create resources, rather than doing everything, getting to the end and trying to deploy it, and you're left with a mountain of errors you have to work your way through. There's nothing more frustrating than deploying something, getting an error, fixing it, going back, getting another error, and just having to work over error and error and error, as you go on. So try and deploy often to make sure that you're catching those errors as soon as possible. So let's hop over to the command line and we'll go ahead and look how to deploy that. Okay, so we're the command line in the same folder as our template. The first thing we're going to need to do is create a resource group. We're going to have a look later about creating resource groups with the actual template, but for the minute with our testing, we are going to create it manually using the CLI. So we just use the AZ group create, and we're going to give it a name of Lambda API-dev. That's what we're going to call it. And we need a location for that. So we're going to put that in West Europe. Okay, so we've created that resource group. So now we're going to go ahead and deploy the actual template. So the A group deployment create command. Pass in the resource group name, which is that one we just created. And we need the template file, which is going to be that core. We're in the wrong folder there, so we need to be in that Bicep. Okay, so that's going to deploy that to that resource group using that template file. Let's see if that works. Now you can see, first of all, we've got a deprecation message. I need to remember to switch to the new AZ deployment group command rather than the group deployment. They both work, but we'll try and use a new one in the future. But you see, we're also getting a message here that I haven't provided any values for location, and we'll also get one in a minute for prefix because I haven't provided those. So it'll ask us to fill them in. That's great. We'll do that here, but we are also then going to go back and create ourselves a parameters file. So we want to deploy to West Europe. And the prefix, let's call it that for now. And that should go and create the resources for us, hopefully. So that ran through and it gave us an error. So it doesn't like what we've done with the network security group. And if we hop back to VS Code, The issue here is my mistake. This section where we passed in the network security group here, this network security group value is actually for creating the network security group within the virtual network. So what we actually need to do is add some properties in here, and we can go to ID, and then what we want is, and that should do the job. So let's run back to the command line, and we'll run that again. And there we go, that's created the resources for us. And over in the portal, we can have a quick look, and we've got our resource group, and in here we've got the two things we talked about. We've got the NSG, and the NSG has just got the default rules for the moment. And then we've got the virtual network, and if we can have a look in subnets, we've got our subnet 1 with the right address space, and with that lambda dev default NSG attached to it. Now, I've just realized that we've actually created the address space wrong for this subnet. So this subnet 1 is taking up the entire address space for the VNet, which is not what we want. We want to be able to add some more resources in. So we will go back over here to our default value. And so the default value here for the subnets is /20. That was wrong. It should be a /22. This should be all right because there's nothing actually using the subnet yet. So we should be able to redeploy that. And hopefully it will recreate the subnet for us. Okay, that has worked. So let's go back to the portal and just refresh this, and we should back, yeah, it's 22. So we've now got some spare address range there in case we need to add some other resources outside of this. And you can see there we've got the NSG as well. Okay, back to code, and we need to now add a configuration file so we don't have to keep adding in those properties every time. So let's create a new folder, and we'll call it configurations, and then we will create a new file, and we will call it dev.json. Now, if you remember, parameter files in Bicep are not actually Bicep at all. They are the actual same parameter files we used in ARM templates, so the JSON ones. Unfortunately, if you've only got the Bicep extension installed in VS Code, there isn't actually a snippet for creating the JSON parameter file, unfortunately. So instead, I've just taken the code from the Microsoft docs, so we'll just paste that in here. This is the parameters file. That's fine. And so we want to create a parameter file. So we've got two variables we want to pass in here. Helps if I can spell. And we've got presets. So we just want to take the values we were using previously. West Europe for the location, and then lmbd-dev for the prefix. That's all we need for now. So we've saved that in our configuration folder. We've got a file there called dev.json. We will add in test and prod parameter files as well in the future. So we'll have them all stored in the same place. If we go back to the command line. So here we are back in the command line. We're going to run the command we ran before to do the deployment, but this time we're going to add the parameters flag. And we need that from configurations dev.json, this is what we created before. Just need to stop to the syntax slightly to pass the content in for that file. And if we run that, that should take the content of that file, and it shouldn't ask us for any of those options because it's pulling them straight from the file. And there we go, that's deployed correctly with the values we passed in. So we've now configured our properties file, parameters file, sorry, so that they're passed in now. So we've got everything we need now to start building our resources and adding to as we go forward. So we'll stop there for today. Next week, we're going to have a look at the core Bicep file some more, and we're going to start adding some more things in. So we're going to probably focus on adding in the Cosmos DB database and setting that up with private endpoints on our virtual network that we've created here. So we'll be layering on more stuff as we add more resources. So hopefully that all made sense. If you've got any questions, feel free to put them in the comments. The code we've got here will be uploaded into the Git repo, which I'll link to as well. But this Git repo I'll be adding to as we go along with this. So if you want to follow along and you need to look at any of the code, that Git repo is the place to go. And hopefully I will see you next week when we start expanding on that further.